As you can see from the illustration here, the kerf is the width of your laser beam that is removed from your material as it cuts. So let's take a look at an example of how that would affect a 1 inch by 1 inch square being cut out with your laser. Now the way your laser is programmed to move is by connecting each endpoint together. So in this case, we would start at one corner and the laser would move 1 inch in each direction until it reaches back to the original start point. Now the problem with this is the laser actually has a width to it, so we'll be removing material on both sides of the line that it's following. So as you can see here, as the laser is following the path of the line, it is removing material on both sides of our 1 inch rectangle that we designed. And this material that was removed by our laser is called the kerf. Now every laser will have a different kerf width. So let's say for an example we have a 0.08 inch kerf width. And as you can see here, if we were cutting that square out to fit something inside of it, the square would actually be bigger than our original design because half of the kerf width cut on the outside of our line, and that actually made the cutout bigger. So if we were trying to fit something perfectly inside of that square, it would slightly be a little bit loose because of that kerf width. Now on the other hand, if we were trying to cut that square to be a perfect 1 inch square, you could see we're going to have the same issue because half of the kerf width was cutting on the inside of that line, and now our 1 inch by 1 inch square is smaller because our kerf width took away half of the kerf width all the way around. So let's take a look at how we can compensate for this kerf width. Our first option is using a pair of calipers to manually measure your material thickness, but the problem with these is you have to manually figure out your kerf width. So each time you use these, you'd have to manually add in half of your kerf width on each side of your material, and that can get very confusing at times. And also a good pair of calipers is usually very expensive. Our next and easier option to use is using a custom kerf tool that works perfectly with your laser machine. To use this tool, just simply go to kerftool.com, where you can buy the instant download file to cut out on your laser machine. Once you have this file, just cut it out on your laser, and it is very important that you cut it out on your laser because every laser's kerf width is different, so this will account for your kerf width as you cut it out. Now once you cut this out just one time, you'll be able to use this on all your projects. So to use this, just take a piece of material that you're trying to fit into a laser cutout, and you could slide it into each slot opening until you find a good fit. Once you find a slot opening that fits good, just take that corresponding number and adjust your design to fit that number, and you'll get a perfect fit every time because that cutout is already compensated for the kerf width of your laser.